Hey guys, let's discuss a new meta interview loop round, and which is round 7, which is called distributed. You have to design distributed systems. Sorry, the round is called distributed system, and you have to design real-time live comment platform. So, what is real-time live comment platform? Let's say you have done some comment real-time. I can see that, or you can say one YouTube live is happening. Okay, so and then lots of people has been joined in that live, so everybody should see everyone's comment. Okay, live in a live feed comment section. So here we will be seeing answer based on two rules, L5 and L6. L4 also use the L5 answer. Okay, so expectation differ by level. E5, not L5, E5 and E6. So E5 is senior software engineer, E6 is a staff engineer. Senior software engineer would expect to say design a scalable real-time comment service using WebSocket, Kafka and Redis. Okay, and E6 staff engineer, so he will say that design Meta's global live comment platform supporting millions of concurrent viewers, AI moderation, then multi-regional deployment and high availability. So step one would be functional requirement, let's say. Okay, so functional requirement, what will come in functional requirement? Uh, okay, so see, the system should, system should do. The first one is post live comment. Okay, display comments in real time. After that, support millions of concurrent viewers, moderate inappropriate comment, rank comment, prevent spam, support or likes reactions, and then maintain ordering. Okay, then step two is non-functional requirements. So here your millions of concurrent users, the system should support millions of concurrent user, end-to-end latency 200 less than 200 millisecond, and high availability, horizontal scalability, fault tolerance, and cost efficient. Okay, so what E5 will say? E5 will say that I would build an event-driven architecture. Here he is using event-driven architecture, asynchronous communication. Okay, queue, Kafka, messaging queue, RabbitMQ queue, these things. So where users send comment through WebSocket, okay, and then comment are published to Kafka, processed for moderation and ranking, cached in Redis, and pushed to the connection viewers in the real time. So see here, two-way communication. If you wanted to establish communication between two devices, you can use HTTP or you can use WebSocket. In HTTP, you send the request, you got the response, that's it. Okay, connection close. But in WebSocket, the connection is open. Okay, so two-way communication happens there. Usually for the chat system, we use the WebSocket. Okay, or you can use SSE also, server-side streaming event, right? So there just one way communication, just one system is sending the continuous communication to other system just listen that. So we will not use SSE here. We will see the difference between WebSocket and SSE. Okay, so now high level architecture, if you see, so user will send the request. Okay, it will go to load balancer. From there it will go to WebSocket gateway, and then Kafka. Okay, comment service. So comment services are application, then moderation service. So moderation service means it will moderate. In earlier video we have seen, we have designed the moderation service, right? It will check if the content is safe or not. Otherwise it will block the content if it is not safe. Else it will allow the content, or it will just go to human loop where human will review manually, and then he will approve or reject. Then from there it will go to Redis, then WebSocket broadcast. Okay, so WebSocket we are using here, so multiple viewer can see at the same time that comment. So E6 staff engineer, he will say that at meta scale, I would separate connection management, okay, comment ingestion, moderation, ranking, everything he has created separate service, okay. Then caching, AI toxicity detection, that is our moderation engine, okay. No, AI toxicity detection means related to AI only. AI will detect the toxicity there. Then broadcasting. Okay, Kafka would decouple producer and consumer. Redis would cache hot streams, and multiple region would serve viewer with low latency. So here Redis would cache hot streams. Hot streams means, let's say, one particular one live feed is going, okay, and it is very popular. So for all the comments related to that live feed, because you will be getting a lots of comment, okay, it is a popular one. So everything will go to one Kafka, let's say, partition, okay, and in partition we know partition guarantee the order, right? So there it will order the comments. You need to maintain the comment order also, right? So using timestamp or ID, we maintain it using the number. So now let's talk about enterprise architecture. Okay, so users request will go to global load balancer. There you have a multiple services. Okay, so request will go to multiple services like WebSocket gateway, comment service, moderation service, ranking service, and notification service. From there it will go to Kafka, then Redis cluster, and then broadcast workers, and then millions of clients you will be having at the same time will see that comment. So now let's talk about few follow-up question, which is the very first follow-up question, which is very important: difference between WebSocket and SSE. So see, WebSocket is like imagine one situation. Okay, imagine you're on a phone call with a friend. You can speak whenever you want, and your friend can also speak whenever he want. Okay, without waiting. Similarly, WebSocket creates a persistent connection where both the client and the server can exchange the message at any time. This makes it deal for application like chat system, multiplayer games. Okay, you can use this kind of thing in chat system or multiplayer games, collaborative document editing, trading platforms where both sides continuously send and receive data. So here the advantage is full duplex. Okay, server and client and server both can communicate, and low latency, and client and server can communicate anytime. Now if you talk about SSE, so imagine you're watching a live TV news channel or listening to a radio station. The broadcaster continuously send news updates while you simply watch or listen. If you want to respond, you need to use another medium. Another medium means call them, okay, such as making a phone call. Similarly, with SSE, the server keeps pushing updates to the client over a persistent HTTP connection, but the client cannot send data back over the same connection. Okay, one-way communication only. If the client needs to send information, it must make a separate HTTP request. SSE is commonly used for live notification, stock price, sports score, news feeds, and monitoring dashboards where information flows only from the server to the client. So like server client only, it is simpler one, and then no client messaging is required here. E6 will say for live comments, choose WebSocket because users continuously send and receive messages. Okay, SSE is better for one-way streaming like stock price or notification. Now follow-up question 2 is ordering guarantees. So ordering guarantees, I have already told you. E5 will say maintain ordering using timestamp and sequence number, and E6 will say Kafka guarantees ordering within a partition. So assign each live stream to particular partition. Okay, so for example, you have this live stream is going on, and inside of Kafka you have multiple partitions 0, 1, 2. You will assign that live stream to one partition only, and then that partition will guarantee the order comments. Okay. Now follow-up question 3 is spam filtering. So if I will say that he will filter duplicate comment or excessive posting or blocked keywords, and E6 will say with this he will combine rule engine, rate limiter, and AI spam classifier, and then user reputation score before broadcasting. Okay, so now follow-up question 4 is comment ranking. So how you will rank the comments. So you can rank using like, okay, number of like the comment is getting, or replies, or recency. Okay, the newest comment will be on the top. E6 will say ranking signals include engagement, creator relationship, user reputation, toxicity score, freshness, and ML relevance score. Okay, so now follow-up question 5 is moderation. Check comments before broadcasting. Pipeline will be something like this. Okay, incoming comment will go to AI moderation, we have seen that. Then policy engine, okay, it will fetch policy from vector database, and if it is safe then broadcast it, otherwise human review is required, and then whatever action you have taken, just logged it, okay, in an audit log. Follow-up question 6 is scaling to millions of viewers. So E5 will say scale WebSocket servers horizontally. Okay, and E6 will say, so architecture will be like this: global load balancer will go, the request will go from global load balancer to WebSocket servers. Okay, now here you have a cluster of a WebSocket server, not only one WebSocket. Okay, then it will go to broadcast workers, where you will have a multiple workers, and then will go to millions of clients. Okay, sticky session ensures users remain connected to the same gateway. Now, follow-up question 7 is hot partitions. So, hot partition means popular live events may overload one Kafka partition. Okay, if it is a very popular and we are sending it to one Kafka partition only, right? Because to maintain the order. So that could be overload that partition, right? So E6 will say mitigate using partition sharding. So shard the partition, that partition will be one only, but you will shard it, okay, on multiple servers. Then multiple broadcast workers, Redis Pub Sub, and dynamic partition reassignment. So what Redis does here, so receive the message from the publisher, look up everyone subscribe to that channel, and immediate forward the message to the subscriber. Doesn't store the message PubSub model. So see, you have a PubSub model and you're using Redis for that. Redis is using we are using Redis just only to have a message for very less amount of time. So publisher will publish the message, Redis is forwarded to subscriber. That's it. See here, the advantage is that, let's say you have a multiple subscribers, okay, so you don't need to connect with each subscriber. Means publisher has not to connect each subscriber separately. He will just connect to Redis, and Redis will send all the message to that subscribers. Okay, so without Redis, suppose you have three services: notification, email, and analytics. The order service has to send the same message to each service individually. So without Redis order service must know every consumer. Adding a new service means modifying order service, okay, and then tight coupling. So now follow-up question 8 is back pressure. So back pressure means consumer is sending the message, but producer is sending the message, okay, but the consumer is not consuming it at the rate at which producer is sending, okay. So slow consumer should not block the system. And E6 will say, so implement bounded queue first of all, then buffer limit. You should have some buffer limit, okay. And then message dropping for stale comments. So what is the message dropping? If the comment is stale, then just message drop, okay. Don't process that message. So don't process or deliver comment that are no longer relevant because they are too old or associated content has been changed. So now consumer throttling also, okay, limit the consumer this thing request it is processing. Follow-up question 9 is Kafka integration. Okay, we have 11 follow-up questions, very simple one. So here you will be using Kafka integration. Kafka buffer incoming comments and decouple producer from consumer. Then each service consumes independently. So WebSocket will send request to comments to Kafka, then it will go to moderation service, okay, filter the check whether you need to allow that or not, and then it will go to ranking system and then broadcast. Okay, follow-up question 10 is Redis usage. So cache recent comment for faster retrieval. E6 will say Redis store recent comment, hot streaming, user session, leaderboards, and rate limiter counters. This reduces database load. Okay, so now follow-up question 11 is failover. So deploy multiple instances behind a load balancer. Implement active deployment. We have seen that active passive, right? So Kafka replication, Redis replication, and automatic failover and client reconnection. So that's it. Thank you.